Section 4.1 focuses on the graphs of the sine and cosine function. So both of those are periodic functions. They repeat their values in a regular pattern. So let's do remember, this is important. The period for sine and cosine is 2 pi. That means that's how long it takes to start the repeating. Now, that's if the basic sine or cosine. When you start doing things to the function, that period can change. But let's look at the sine function. So if we looked at a table of values where we had x and y, just an old-time t-chart, and y is sine x. So when x is 0, y is 0. When x is pi over 6, what is the sine of pi over 6? It's 1/2. What is the sine of pi over 4? Square root of 2 over 2, which I wrote an approximation of 0.7 just because if we were going to graph it. Pi over 3 is square root of 3 over 2. That's about 0.9. And then I did the rest. So if you plotted those points and we come up here, if we just do 0, 0, and then we do pi over 2, let me get back and show you. So if we just do these yellow ones, without these in here, so pi over 2 is 1, and then pi is back at 0, 3 pi over 2 is -1, and then we're back here. So we can see the repetition here. We can see the x-intercepts, and we can see the max and the min. Those are the 5 points that we would want to graph if we were hand graphing this. So keep that in mind, that that's what we would like to do. We need to remember that the domain for sine and cosine is all reals. It's going to go on and on and on forever. The range, y, has to land between 1 and -1 if we look here. The x-intercepts are every multiple of pi. So if we look back at the picture, we have 0, we have pi, we have 2 pi. It would hit again at 3 pi and at 4 pi. So every multiple of pi. And the period is 2 pi, which we've already said. Now let's look at cosine. Cosine looks a little different. So let's look at the same things here. If we get 0, pi over 2, pi, 3 pi over 2, and 2 pi, we've got these numbers. And when we graph them, instead of getting that full up, down, and back, we get like a U. And so our intercepts were at pi over 2 and 3 pi over 2. We had a high point, and this is just one period. We had a high point at 1, a low point at -1, and we're back up at 1 at 2 pi. So it looks a little different if you're just going from 0 to 2 pi. The domain is the same, all reals. The range is the same, -1 to 1. The x-intercepts are, you're talking about at pi over 2, and then every 2n plus 1. So you could have it at, when n is 0, you could have pi over 2. When you have n is 1, you've got 3 pi over 2. N is 2, and so you could go on and you could find all the x-intercepts, and the period is still 2 pi. The amplitude for both sine and cosine is, think of it as that half the difference between the max and the min values. It is the absolute value of that distance. In the basic formula for sine or cosine, there's a number in front of sine and cosine. If it's 1, then the amplitude is 1. But if it's 4, the amplitude's 4. If it's 1/2, the amplitude is 1/2. And your amplitude will never be negative. It is absolute value of that. We've talked about the period, how long it takes the graph to repeat. Now, that's on what I said was the basic sine x or cosine x. But sometimes we begin to change it. And in the formula, a sine bx. And so the period here is 2 pi divided by whatever this b is. So let's look down here. So the period for sine and cosine is 2 pi over b. If there's no number in front, that's understood to be a 1, and your period is 2 pi like we said. But look at this one. Y equals -4 sine 3x. The amplitude is 4 because it's the absolute value of this one. The period is 2 pi over this number, so 2 pi over 3. That means it's going to be squinched in more. It's going to repeat every 2/3 pi, not every 2 pi. It's going to be squinched in. All right. Now, if you were graphing by hand, which you will have to do, here are the steps for that, and we'll go over those. But you want to find the period to start with. And if it's 2 pi, great. You're going to start at 0. You're going to end at whatever the period is. So if it was 0 and 2 pi, that's what you'd have. If it was 2 pi over 3, that would be this last one. You have a start, you have an end. Then you're going to divide the interval into 4 equal parts. Evaluate the function for each of the 5 x values resulting. Remember how we graphed up at the top of this lecture note part? The yellow items, those were the x-intercepts and the max and mins. That's what we're going to be looking for. So let's go down here, and you'll see what I mean. This chart will be important because you'll do that in your test, I believe, on chapter 6. You'll have to do one and submit it. So if we're graphing y equals 4 sine 2x, first thing, we want to find the period. Period is 2 pi over 2, so the period is pi. So in our chart, you have 5 blocks. You want to start with 0, you end at pi. To get this one, you say, what is halfway between 0 and pi? Well, that would be pi over 2, 1/2 pi. Between 0 and pi over 2, what's halfway between there? Pi over 4. 1/4 is halfway between 0 and 1/2. What's halfway between 1/2 and 1? That'd be 3/4. So that's how you fill in this column. Across the top, you start always with x, and then you build. So you start out with x, then you put 2x, then you put sine 2x, and you end with the whole function. All right, so then in this column, I'm multiplying the yellow items by 2. So that's 0. 2 times 1/4 is 2/4, which is 1/2. 2 times pi over 2 would just give me pi. 2 times this gives me 6 over 4, which reduces to 3 over 2. And 2 times pi is 2 pi. Then you write, what is the sign of this column? And remember, for those numbers, for 0, pi over 2, pi, 3 pi over 2, and 2 pi is back here, you know those on the unit circle. 1, 0, 0, 1, -1, 0, 0, -1. These are easy, and it'll always end up being that. So the sign of 0 is 0. The sign of pi over 2 is 1. The sign of pi is 0. The sign of 3 pi over 2 is -1, and back here you're at 0. So you have these. Then you multiply this column by 4. 0, 4, 0, -4, 0. You're going to graph. These are the x values you graph. These are the y values you graph. So look here. When x is 0, y was 0. If we look back at our blue, x is 0, y is 0. At pi over 2, x is 4. Pi over 2, let me look back. Okay, I was looking down here. We'll just mark these out because that was built in and that was not the things. Okay, so at pi over 4, we're at 4. At pi over 2, we're back at 0. At 3 pi over 4, we're down at -4, and at pi, we're back at 0. You connect those dots, and we have a period of this particular sine function. Okay, and so we talked about how to get these other 3 points. You're finding halfway between, and ultimately you're graphing these x values with these y values. So we'll do some more of that. That is the chart that is in handouts. It's called the Trig Graph. So you can see you've got the part to put here where you get your intervals, here where you build your function, and then you do each column this way. You can set this however you want. If you want 3 blocks to be pi over 4 and 3 more would be pi over 2, however you want to do it. And if you want 3 blocks to be 1 and 3 blocks to be -1, you get to set the graph intervals the way you want to do, but you'll want to print that and be practicing on doing those. All right, let's go look at the problem sets on the homework. Okay, so for number 4, we're graphing 2/3 cosine x. So we know the amplitude is 2/3, and we know cosine is not going to go through 0, 0. It's going to go through 2/3 on the y-axis. So if we look over here, we first notice that the scale is from 0 to 2, and it's got hash marks. So it looks like right here would be 1. So this one is definitely not it, because that's going in there above 1. This one's going below, that's upside down. This one's looks like a sine. So this one, the amplitude does look like 2/3, and it does go through that on the y-axis. So that's how we would pick that one. All right, determine the amplitude of the function y equals 4 sine x and choose its graph. So the amplitude is 4. It's that number right there. And so we know that it's supposed to go through 0, 0, and it should be coming up like that. This one's going down. This is a cosine because it's going through the number on the y-axis. This one's going upside down. This one is not anything that we need. And so this one should be it. You could graph this on your calculator. You want to be sure and be in radian mode and put in y equals 4 sine x. Change your window to match. The x min is -2 pi, x max is 2 pi, and then the y's are -6 and 6. Y equals 5 cosine x. Your amplitude is 5, and so it's going through 5 on the y-axis. And so this is the one that is doing that. It also has to go down to 5. So this one is the correct graph. Number 7, y equals 3 sine -x. The amplitude is 3. Sine goes through the origin, but because it's -x, it's going to go the opposite direction. Remember how I've been saying it goes up? Well, this one is going to come down through the origin, and so that is our graph. Graph y equals cosine 1/5 x. So this is the first time that we're getting something a little bit different. The period is 2 pi over b, and b is 1/5. So 2 divided by 1/5, flip that, you get 10 pi. So your period is 10 pi, sorry. What is the amplitude? The number So number 10 says graph the function over a 2-period interval. Give the period and the amplitude. So y equals cosine 3 pi x. The period is 2 pi over 3 pi, which is 2 over 3. So we know it's cosine, so we should be looking for a U shape. And because it's a 2-period interval, we are going to have 2 of those U's. This picture, we went from 0 to 2/3, that was 1 period, Here's 0 to negative 2/3. That's another period. So that appears to be our graph. The period is 2/3. The amplitude is 1 because the number here is an understood 1. The function graphed in number 11 is the form y equals a sine bx or a cosine bx. That's a general statement for this. So determine the equation of the graph. Well, if we look here, we start up here at 2. That kind of indicates that it's going to be a cosine. And it repeats at pi over 2. So the period 2 pi over b is pi over 2. Let's cross multiply. We get 4 pi equals b pi. Divide by pi, so b is 4. All right, so the b value is 4. It goes up to 2 and down to negative 2, so 2 is the amplitude. So when we write that graph equation, 2 cosine 4x. Let's look at 12. Same thing. We are trying to figure this out. This does go from start at 0, 0, go through there. Looks like it starts to repeat at pi. So 2 pi over b is equal to pi. b pi equals 2 pi. Divide the pi over, you get b is 2. The amplitude is 2. We can see that in the graph. Because it goes down instead of up, we're going to have a negative. So negative 2 sine 2x. That's how we get that graph. Number 13. Below is an example of a periodic function relating feet to time. What is the period in hours? Well, let's look at this. Where does it start to repeat? So if I have this and I come to here, then it looks like it then starts to go again and do the same graph, but that's where it starts to repeat at 24 hours, and that's what it's trying to get you to see. So hopefully you have a feel for, at least a beginning feel, for the graphs of sine and cosine.